And we're off. So this is the third session, Sharpening Asset Management Strategies for Water Utilities. We have three speakers from Covington Water District, Chris Guest, Tom Keown, and Dan Sleeth. And they will largely be taking it from here. Chris, do you want to take control of the screen?
Sure, thank you. Hi, my name is Chris Guest, and I'm the business analyst here at Covington Water District. And today I have with me Tom Cowan, our general manager, and Dan Sleeth, our operations manager. Today, we would like to share our asset management development journey, offer some lessons learned and advice you can take to sharpen asset management strategies within your organization. I'm going to run through a broad overview of our asset management system, the evolution of our asset management program, and then offer some lessons learned to those who might be starting out and developing their asset management program. Then Dan is going to speak to management strategies for operations and maintenance optimization. And then finally, Tom will highlight management strategies from our asset management outputs, such as future funding requirements and capital improvement decision making. The Covington Water District is responsible for providing water to a 55-mile area in South King County, serving a population of over 50,000 through 18,000 plus connections. The district was formed in 1960 with less than 100 customers, primarily around Lake Morton. Over the years, a small number of districts have merged into CWD, and more customers were added as development occurred. The district's water supply consists of groundwater via our production wells and water from the Green River watershed via the regional water supply system. The district has 12 production wells, 4 treatment plants, emergency interties with 2 neighboring agencies, and 20.6 million gallons of storage in steel and concrete tanks at 9 locations throughout our district. And we also have approximately 290 miles of pipeline. In 2019, the district saw $2.6 million in developer extensions and produced 1.8 billion gallons of treated water. This year, our average daily production has been about 5.4 million gallons per day, with a peak day this summer of 9.77 million gallons. As the district grows within our service area and development continues, there's actually an ever-growing need to plan for the future. So the question Covington Water District, as well as all critical infrastructure faces, is what is required to continue the operation of our infrastructure into the future? This requires the knowledge of several things: what our assets are, where they're physically located, what is required of our assets, when will those assets fail, what if those assets fail, who maintains those assets, when and how are those assets maintained, which assets are most important or have priority, and finally, with what funds will those assets be maintained, repaired, upgraded, and replaced in the future. We knew Covington Water District's infrastructure was relatively young. Nearly all of it was installed after 1965. But we also recognized the problem faced by all infrastructure is that if we didn't decide how to pay for it, then somebody else would need to. And the Covington Water District's mission statement and vision speak to a commitment to strategic planning and a vision of tomorrow with action today. So out of those commitments comes the need to develop strategic planning for our infrastructure. So in alignment with our mission, the district began its asset management journey. So over the last decade, the district has implemented an asset management program within an asset management framework. This began with the development of an asset register to identify what our assets are and where they're physically located. We also began to identify failure modes, remaining useful life, and current and historic replacement costs for our assets. And this has allowed us to understand when we can expect our assets to fail and what the financial implications of those failures are. The district also began to set levels of service and begin to benchmark those levels of service. And that allowed us to understand what is required of our assets into the future. So through that work, we've actually been able to come up with business risk exposure scores for all of our assets to say which assets are most important and have priority over other assets. So establishing the current state of our assets and the required sustained levels of service have really allowed the district to begin applying better insights into our capital planning and maintenance and operations planning. And we've been able to determine with what funds we're going to use to maintain, repair, upgrade, and replace our assets into the future. So this better data that we've been collecting is really made for better decision making and better planning for the future. I'm going to cover the current state of our assets and how we got there, and kind of the overall journey to establishing this asset register. And then I'm also going to talk about the required sustained levels of service exercises that we went through and some of our benchmarking examples and what those meant to us. And then that'll move into Dan's talk about developing and working these maintenance optimization programs. And then finally, Tom will talk about the CIP business case development and show off some of our future funding needs calculations. So the real work developing our asset register began in 2011 when the district made the investment into data collection by providing operations and engineering staff with GPS instruments to use in the field. But as technologies have evolved over the last decade, so has the district. Our newest GPS technology is EOS Aero Gold units that integrate with Esri collector application and allow operators to use their cell phones to collect accurate data within 1 inch in the field. But our process, it really began rather slow collecting this geodata as regular maintenance activities took operators to fire hydrants, valves, meters, etc. But slow and steady wins the race on this activity, and we made a commitment to providing resources, and that really is the best way to achieve results. Because initially operators found data collection frustrating and time consuming, but finding efficiencies and keeping up with advancements in these technologies is key to expanding GPS capability and streamlining processes. So we're utilizing ArcGIS as our geographical information system, so we could begin using maps, analyzing mapped information, and managing geographical information in our database. But what we quickly learned here is how important QA/QC of our data was as it came in. And this is an important note for anyone beginning the development of their asset register, is to ensure that you document processes and procedures for data collection, QA/QC, and then ultimately the entire data cycle. Because early on, we frequently had massive influxes of new data, and it frequently required a lot of auditing, correcting. And this is normal when you're starting out, just due to, in large part, the sheer amount of data that has to come in. But having clear processes and procedures will really reduce the time spent in QA/QC. And fast forward to today, the district is in relative maintenance mode with this new geodata that's coming in, because it's mostly coming in through developer extensions and capital projects. But this data is captured by our engineering department during construction inspection, and then it's QA/QC'd by our GIS team prior to pushing it into our software packages and updating our asset register. And that has really helped with the data workflows. So while this data was coming in through the geodatabase and we were building this asset register, we began using CMMS software, which we chose Lucity for our CMMS, and we began to soft launch it in the field. This took the data that we collected and allowed us to track maintenance and repairs, as well as provide for more inputs into our asset register, such as nameplate information and condition scoring. The district began rolling out these maintenance programs one by one to our operations department. And to effectively roll out these programs, you really need to have a champion within your department and find the area or program where the addition of CMMS software would have the greatest positive impact on end users. In our case, it was the fire hydrant maintenance program, which was still in an Excel database, and it just had a lot of problems with the administration of the program. So what we chose to do is put the CMMS in the hands of the individuals who would embrace and support its development, and we really used them as a champion, and we knew that the fire hydrant maintenance program would make a big impact across our operations department. Fast forward to today, all of our essential maintenance and repair functions are in Lucity. So just a note on continuous improvement, we're always looking for new ways to roll out this technology to our end users. Recently, we've expanded our data collection efforts by rolling out Esri's suite of applications to streamline processes for our operations department. And then looking at these technology and workflow improvements should always remain a focal point in the administration of an asset management program, because it ensures end user buy-in. And ease of use is really critical to get everybody in the organization utilizing the tools effectively. So the district was developing this robust data set, bringing in this GIS information and bolstering it with the CMMS data. So we needed a place for it to live. And we elected to use an asset information management software called AIMS for short. And this is from AIMS Team LLC. And this was what we used to complete our asset hierarchy and asset register. To date, our asset register contains 84,941 QA/QC assets. And the software has allowed us to begin applying management strategy inputs to receive future funding needs calculations. But as I alluded to earlier, developing the current state of our assets, it really required some more inputs. So we needed to begin identifying failure modes for each one of our assets classes. And this really helped identify whether demand on an asset exceeded its design capacity, or whether the functional requirements exceed design capacity, or physical deterioration reduces the performance of an asset below acceptable minimums, or just whether the cost of operation exceeds all alternatives. So once those failure modes were identified, we could begin to use AIMS to calculate remaining useful life. And then we had to provide it another piece of data, though, to get our future funding outputs, and that was the critical input of replacement cost. So as the district worked really diligently to develop our current state of our assets, we did run into some hurdles, and we faced some roadblocks, and overcoming those, hopefully I gave you some practical pieces of wisdom there. But our overall journey to establish our asset register has really taken about 9 years of trial and error. So it really is a long journey, and this should serve as kind of a case study that, you got to seek out continuous improvement and just dive into the pool and start out on your development journey. So while we were working diligently to understand the current state of our assets, we also needed to know what was required of our assets. So this meant for us establishing some levels of service, which serve as the parameters or combination of parameters that reflect the outcomes that the district wants to deliver. So levels of service gives the district the means for realizing value from district's assets through the delivery of services to stakeholders. We started by defining who our stakeholders are and what outcomes we deliver them. And then once those were identified, we began to audit whether or not we were actually meeting those needs. And when you begin levels of service exercises, it's important to note that the outcome you deliver need to be in line with your organization's mission and vision, as well as industry standards and regulatory compliance. When defining stakeholders' needs and current levels of service, you need input from all levels as well. So elected officials, management, staff, and most importantly, your customers. But once you understand where you are, you can begin to establish where you're going. And in similar fashion to how we define needs and current levels of service by receiving input at all levels, we begin to do the same to establish goals and standards for our level of service. Again, these were directly in line with our organization's mission and industry standards. But once you know where you want to go and you've established these goals, you can then begin benchmarking to ensure your organization is headed in the right direction. So here's a few examples of our early benchmarking findings from our original benchmarking activities. One of our levels of service involved financial stewardship. So a goal was to reduce the district's debt ratio. And this is a simple benchmark to compare our debt ratio with other water utilities regionally and nationally. The debt ratio benchmark quantifies the utility's level of indebtedness, rather. It is a measure to the extent in which assets are financed through borrowing. So the higher the debt ratio, the more dependent the utility is on debt financing. As you can see, we've been able to reduce our debt ratio, and we've actually maintained this debt ratio through the end of 2019. Here's a look at an operational benchmark that incorporated environmental and financial stewardship. This indicator quantifies the energy consumed to supply potable water on an annual basis, normalized by water demand in millions of gallons. So becoming more energy efficient has been a strategic goal of the district, and this benefits not only a reduction in cost of the energy we consume, but it also reduces our environmental impact. This is an excellent example of using multifaceted goals in order to achieve a level of service. So in order for the district to make progress towards becoming more energy efficient, our operations staff began to look at system control changes to become more efficient. So for example, adjusting start and stop set points on pumps to reduce demand charges from multiple pumps running at once. Likewise, our engineering department began CIP projects to make our headquarters buildings more energy efficient. This included the installation of this hydroelectric turbine that uses water from our transmission pipeline to supply as much as 80% of our headquarters building's energy requirements. This replaces the electricity the district buys at retail rates. The district was able to identify this opportunity to build the turbine as a part of an existing project to add another transmission line to our system anyway. So the district could have settled for operational efficiencies as being good enough to meeting our benchmark and meeting our goal, but we reevaluated our levels of service and asked, could we do better? And this allowed us to capture this opportunity to spend a little more capital on a project for a huge ROI. So establishing levels of service will provide your organization an understanding of what your stakeholders need and a roadmap to your future. So it's worth the time and effort to understand and perform these activities when you're administering an asset management program. So I hope that's kind of giving you a good background. And now I'd like to pass the presentation over to Dan Sleeth, our operations manager, who's going to speak a bit more about the risk assessments that we did. And then he's going to give you some insights into management strategies for operations and maintenance optimization. And I'd like to thank you for my time here, and I hope you guys enjoyed the background on our program. Thank you.
Thanks, Chris. As Chris mentioned, my name is Dan Sleeth. I'm the operations manager here at the Covington Water District. I've been here just about 4 years now, and I have been in the drinking water industry with a public utility for 34 years. It's my pleasure to take over this middle part of the presentation for you guys and speak to you about some of our process that we put into place that Chris spoke to a little bit. And I'd also like to talk a little bit about methodology as we put these into place. So starting with establishing our risk ratings, one of the first things we wanted to do was work on condition and condition scoring, and to make sure that we had a clear, concise rating protocol for our entire team to utilize that would ensure uniformity. This will create some good benchmarking and stability across when we start rating our different assets, because of course not all assets are created equal, but what we did want to create equality is how everybody viewed condition scoring. We settled on a protocol that utilized some of the 5 why principles used to validate root cause analysis, which is one of my favorite processes to deal with. Our condition ratings model incorporated 5 areas. First, a definition for our rating system, which is 1 through 5. 1 being excellent, 5 being failing. And then across those, we use that based on operations, maintenance levels, maintenance type, and useful life. Once we did that, we could complete our historical data to determine reliability and performance of our assets. Of course, redundancy is a vital part of any utility and must be considered when calculating your BRE. System design is at the forefront of our thought process. Design it right, build it right, operate it right, maintain it right. That leads to consequence of failure. Our utility is using triple bottom line in our strategic plans, so we're always looking at economic, environmental, and social consequences when calculating our consequence of failure numbers. When we multiply all those together, we get our business risk exposure. Once that was completed, we then began working on filling out our FEMA table, not to be confused with FEMA, the Federal Recovery and Disaster Team. FEMA table is a failure modes and effects analysis matrix. This risk matrix allows us to look quickly across our 90,000 assets and see exactly where we sit in terms of high risk, medium risk, and low risk assets. As you can see in our table depiction, our district has very few high risk assets at this time, which is in direct correlation with our age. Being what our general manager likes to refer to us all the time as a frisky teenager, our district, for the lack of better terms, is 60 years old, but we didn't see a lot of growth the first 10 to 12 to 15 years of our existence. So in effect, we're between 45 and 50 years old, which for public utilities is fairly young. So being that has its benefits when it comes to managing our utility. Most of our pipes are ductile iron. Most of our storage facilities meet current code for earthquakes. Our pumps are proper sized and have plenty of redundancy, all which lead our district to being in a fairly good place right now in 2020. Earlier in the presentation, I don't know if you caught it or not, but Chris had some slides up that were showing our AIMS program, our Asset Information Management System, and it showed a 100-year forecast. And you could see some spikes in the bars that were, I think right around 2057 in that area. And that at that time, that's when we're going to be facing much more financial impact. A little bit later in this presentation, Tom will talk to you a little bit about how we're utilizing all this to make decisions for our CIP projects. Next up, we used a concept called the decision tree. The decision tree has tremendous potential as a as a decision-making tool. The decision tree can clarify for management, as can no other analytical tool that I know of, the choices, risks, objectives. Personally, I'm a big fan of decision trees, 5 why tools, and process in general that enables you to consider all the different outcomes based on probability, risk, and consequence. As you can see in this tree, starting at the top, identify your critical assets. What is the failure mode? Is there redundancy? What's the consequence of failure? What's the risk associated with the consequence of failure? If there's redundancy, what's the probability of failure? What's the timing of the remaining useful life? As you work through these, you can see that it helps you establish a solid risk rating. Think of all these decision event chains that are required just to pull off something as trivial as a wedding. Yes, I said it. Of course, I can say that because I'm not married. But seriously, think of all the potential for decision event chains to accommodate for an outdoor wedding. Is it going to be sunny? Is it going to be rainy? What are all the different outcomes that I have to prepare myself for all the potential that could go well or could go wrong? This is a really fun way to work through this type of exercise. Of course, we don't have time to do that in this setting. However, I would recommend that you take this approach with staff if they're having any mental roadblocks for this type of process. This slide outlines a little bit more of that decision and event process within the tree. So, developing your risk reduction and your failure management strategies. Is there a high probability of failure? If yes, identify technically feasible options. If no, managing your consequence. What's the cost of failure? What's the triple bottom line? Is it an environmental impact? Is it a social impact? Maybe it's all three. If the answer is yes, what's your feasible options and what's the cost of those feasible options? And dropping down, cost to fix greater than cost to let fail. Yes, run to failure. Run to failure is a huge part of our strategy for many of our assets, but not all of them. And if not, implement the fix. Again, like I spoke to earlier, not all assets are created equal, and they should not be they should not be treated as equal across the board. You should have independent strategies. Within our current AIMS program, I think we're up to about 15 different management strategies now, depending on the type of assets, the probability of failure, the consequence of failure, and how we are approaching those assets. The beautiful thing about management strategies, and especially within our AIMS program, is it's a constantly evolving strategy. We're using the best available data that we currently have to make these strategies. However, it does not mean that the strategies cannot be changed, adjusted, or even eliminated if that might be the best option. So it's an ever-evolving process right now. Just as a quick example, within our hydrants, our fire hydrant maintenance and management strategies, we currently have 3 different strategies depending on the age, the type, and the history of failure that we've seen. So that's just one easy example of a very easy asset to deal with. So we all know fire hydrants are really not that complex, but they are a huge part of any drinking water utility. This takes me to management strategies, operations, and maintenance optimization. So when I first started here almost 4 years ago, our general manager asked me if I could explore the depths of RCM, which was new to me. I have been in the drinking water public utility on the operations side my entire career. So at that time, about 30 years, had no experience with RCM. So I was very excited to dive in and learn about its concepts. What I found is there's just some fantastic principles involved with this. And this is kind of there are 9, it's almost our commandments. So number 1, accept failures. Not all failures can be prevented by maintenance. Some failures are the result of events outside our control. Think lightning strikes or flooding. For events like these, more or better maintenance makes no difference. Instead, the consequences of events like these should be mitigated through design. And maintenance can do little about failures that are a result of poor design, lousy construction, or bad procurement decisions. In other cases, the impact of the failure is low, so you simply accept the failure. Good maintenance programs do not try to prevent all failures. Good maintenance plans and programs accept some level of failures and are prepared to deal with the failures. Number 2, most failures are not age-related. The likelihood of occurrence is random. Some failures happen in infancy, and we'll talk a little bit more about this when we hit our next slide. Number 3, some failures matter more than others. This speaks to exactly what I talked about when not all assets are created equal. Number 4, parts might wear out, but your equipment breaks down. Number 5, hidden failures must be found. This is an interesting concept to dig into. Hidden failures are typically failures of one or more components aligned in parallel with no indication of failure for each individual component. For example, one of 2 components could fail, but since each one by itself can satisfy the function, only when the second one fails will the functional failure become evident. Therefore, the failure of the first component is potentially critical. These must be identified. Number 6, identical equipment does not mean identical maintenance. Simply put, think about your pump station, and if you have pumps in parallel, and if your staging those pumps isn't equal across them. If your pump number 1 is the one you rely on all the time and you're not staging them, pumps 2, 3, 4, and on are going to have a much different maintenance schedule. This is a good basis for making sure that you are staging things properly and that you are utilizing your equipment as equally as possible. Number 7, you can't maintain your way to reliability. I love this quote, and it's very true. Maintenance can only preserve your equipment's inherent design reliability and performance. If the equipment's inherent reliability or performance is poor, doing maintenance will not help. No amount of maintenance can raise the inherent reliability of a design. To improve poor reliability or performance that's due to poor design, you need to change the design. It's that simple. When you encounter failures, defects that relate to design issues, you need to eliminate them. Sure, the more proactive and more efficient approach is to ensure that the design is right to begin with. But all plants start up with design defects, even proactive plants. And that's why the most reliable plants in the world have an effective defect elimination program in place. In a few slides from now, we'll talk about the importance of starting this cycle with designing it right, building it right, procuring it right. Number 8, good maintenance programs don't waste your resources. This seems obvious, right? But when we review PM programs, and we did here at Covington, we often find tasks that add no value. If you asked any of my staff, they would tell you that they get sick and tired of hearing that exact phrase from me. That's the one thing that I harp on. I want value-added tasks. Tasks that waste resources and actually reduce reliability and availability. It's so common for people to say, let's check this, let's do this. It only takes 5 minutes. But 5 minutes here and 5 minutes there every week or every month when it's not needed is suddenly a waste of a lot of time. Principle number 9. Good maintenance programs become better maintenance programs. The most effective maintenance programs are dynamic. They are changing and improving continuously. This is the one thing I love about working at Covington Water District. We hang our hats on continuous improvement. I love that. When improving your maintenance program, you need to understand that not all improvements have the same leverage. First, focus on eliminating unnecessary maintenance tasks. This eliminates the direct maintenance of labor and materials, but it also removes the effort required to plan, schedule, manage, and report on this work. Second, change time-based overhaul or replacement tasks into condition-based tasks. This is why it was so critical for us to get a condition scoring matrix that put everything on a level playing field for all operators. And third, extend task intervals. Do this based on data analysis, operator and maintenance experience, or simply on good engineering judgment. Remember to observe the results. The shorter the current interval, the greater the impact when extending that interval. For example, adjusting a daily task to weekly reduces the required PM workload for that task by more than 80%. Often this is the simplest and most effective improvement you can make, and is some of the improvements we've made across many of our maintenance programs. This slide gives us a good look at failure patterns and understanding failure patterns. Random failures. The term life cannot be used to describe the point of rapid increase in the likelihood of failure, as there is no specific point. These are the flat parts of a failure curve. These types of failures occur due to some introduced defect. Infant mortality. The term life cannot be used here either. Instead, there is a distinct point at which the likelihood of failure drops dramatically and transitions to a random level. Understanding these unique differences, an effective maintenance strategy can be developed. Age-related. These types of failures can be addressed through fixed-time maintenance. Fixed-time maintenance includes replacements, rehabs, overhauls, basic cleaning and lubrication. While cleaning and lubrication will not prevent the wear or will not prevent wear out or corrosion. It can extend the life of the equipment. Random. These types of failures need to be detected as they are not predictable or based on a defined life. The equipment must be monitored for specific indicators. These indicators may be changes in vibration, temperature, flow rates, etc. These types of failures must be monitored using predictive or condition monitoring equipment. Okay, here's where we get to our design, installation, potential failure, and failure, your depth curve. Design. What was once left off the original versions of the curve might well be one of the most critical aspects of equipment health. Is the motor that was selected the right one for your application? Is the structure the motor attaches to properly secured for the forces that will be applied? Does the pump have enough head pressure to lift the fluid up and through the system? All of these questions make up design aspect of the curve. Installation. Any system can be foiled by improper installation. Transportation of the equipment can affect reliability and operational life of the equipment. Installation lets the roots of design reliability take hold. A house built on sand will fall many years before the house built on solid ground. It's imperative that proper installation techniques be applied to ensure a healthy, reliable system. Potential. Regardless of how well a system is designed or how perfect the installation was, failure will occur. P is not where equipment failure occurs, but rather where failure can be detected. The time between installation and potential is where predictive maintenance should be introduced. It's during this time that data can be trended to discover the potential failure point. Functional failure. Once the equipment enters in the functional failure point of the curve, it is no longer producing the results it was designed for. This could be a pump that loses flow and head pressure, or a motor that will trip out on overcurrent. Operational monitoring and repair costs all increase when equipment loses core functionality. Repair costs increase in unplanned downtime, and the time frame to return to service is shortened. Catastrophic failure. This happens and will happen to everyone. It can happen even with the best maintenance practices in place due to an anomaly. Using condition-based monitoring will reduce the possibility of this happening substantially. Defects that affect our optimization, and the sources of these defects. We have defects from the quality of materials, defects from workmanship, defects from failure events, defects from design, and defects from operations. Many defects ultimately lead to failure. They're either introduced through operations or detectable by operations long before they will cause a failure. Think of a cavitating pump or ignoring excessive vibration in a pump. A traditional maintenance-focused technical approach to reliability will focus on the first three sources through preventive maintenance, predictive technologies, vendor audits, parts inspections, and skill training, but will typically ignore the last two sources. When you focus on limiting all the sources of defects as well as eliminating the defects currently in your system, performance improvement will be dramatic. One of my favorite philosophies that go with this is we should be thinking like this as operators and as operations teams, operations leads, supervisors, foremen, and managers. Let's not just fix it, let's improve it. I would be remiss and a hypocrite if I didn't slide in a quick reference to 5Y and root cause analysis. So if we're going to optimize and we're going to go through all of these processes to make ourselves better and reduce failures. When we do have failures, we need to get to the root cause of why. If you've never done a 5 why root cause analysis, I would highly recommend that you research it, go through a couple of examples with your team. They can start out just as simply as this one. My car won't start. Why? Battery was dead. Why? It didn't charge. Why? The belt was slipping. Why? The belt was worn. Why? Didn't know that I needed to change the belt. 5 whys can be a fantastic way to get to root cause analysis and are a fun way to involve your operators, the folks that are actually dealing with equipment and failures on a daily basis. And in conclusion, for my section of this presentation, which I want to thank everybody again for having the opportunity to present this, it really doesn't matter whether you're utilizing RCM principles or RBM principles, which didn't have the time to talk about today, but that's reliability-based maintenance. The point of emphasis is reliability, which is why the cycle is so critical. We've said it before, and I'll say it again, just to make sure that we're hammering home our point. Design it right, purchase it right, build it right, operate it right, and maintain it right. Do these things utilizing data. Data-driven decisions will get you to the promised land. Again, I thank you for your time, and I will now turn the presentation over to our General Manager, Mr. Tom Cowan. Thank you.
So thank you, Dan. My name is Tom Cowan. I'm the General Manager of the Covington Water District. And some things that we've been trying to do over the last couple of years is add more rigor to our CIP expenditures. So over my past almost 3 decades, a lot of the CIP requests come in as kind of a wish list. Not necessarily a lot of backup information, just the respective departments and work groups saying, well, I need this. And while generally that's all well and good, as most of you know, we all have a finite amount of money that we have to make these decisions. So we've been trying to move to a more structured model, taking our asset management plan, which has our entire portfolio in it of almost 90,000 assets, and develop that inventory, getting condition scores, assessing failure modes and what the residual life or useful life is, looking at levels of service and trying to figure out an optimized decision to get the best bang for our buck on behalf of our ratepayers. So as we've been developing our CIP, we have, being a water utility, we have vehicles and wells and tanks and other assets, and this is a look at our 5-year outlook. The lower levels below the $10 million mark are basically our kind of our fixed O&M cost, and while you can usually look at a way to finagle a few percentages out of that, the much bigger variability comes in the magenta colored CIP, which, as you can tell, it's a few $1 million in 2020, but it's several $1 million in 2021 and oscillates back and forth in the future. And then the red at the very top is what our management strategies are telling us for our rehabs and renewals. So right now, our modeling, our financial modeling says that we have a bit of a rock pile in year 1, and then not so much in the ensuing years, which makes sense to us intuitively, just because we're a relatively younger water utility that's still in growth mode. Now I'll get into some more of the details about how we develop this. So scheduling is always big. We do want to make sure that especially for those pending CIP projects, especially the ones that are over $1 million, if you have done a FEMA ROI, return on investment process, we're basically doing kind of a FEMA light activity where we're just trying to make sure that we have the right project for the right reasons going forward in the short term for capital investment. For us, the big one is the top line. We have a tank 1, so its drivers are we need a bigger tank for future growth, as well as we have a level of service deficiency, which is it's substandard in the event of an earthquake. So we've already done an expansive FEMA request for that in tank 4, down at the bottom, where we're looking for potential funds to get FEMA. But then there's some other road projects that we've done business cases just to make sure that they're meeting our needs for smaller things, or some of the smaller projects that are driven by city road improvements. Those are just the level of services comply with the franchise agreement. One thing that we've noted in our work to date is that not all assets respond the same. Some respond to the environment in which they reside in. So here you'll see a density heat map of our service lines, and you'll notice in 3 or 4 places on the map where it's we have a fairly high impact to our service lines, depending on soils and other activities. So when our folks are out there working in the field, they're noting the soil types and getting a sense of what the condition is and for the services in these respective areas. And that's just another tweak to our management strategy, that we can tag these assets accordingly in this area. In this case, if we know we have these service lines in these hot spots, then that can become a bit of a we can play with the timing of their replacement. Basically, we can speed that timing up and get to those service lines, hopefully in a proactive mode and not having to react to a service line repair in the middle of the night. And here's kind of the heart of our management strategies. We have a tool, it's called AIMS. And in AIMS, when we're looking at strategies, we have to create a management strategy for all of our assets. So some are basic, there's just maybe a single strategy, but for things like fire hydrants, if they're put in different years, we know that some have different physical standards that are different than others. So we have some older hydrants that have a lead port that we want to have out of the system, just to make sure there aren't a water quality issue. So if you'll notice there in the 3rd line, there are no possible rehabilitation events, and we want to get those 250 hydrants removed as soon as possible. If you go down in the middle of the screen, you'll see our water meters. So the useful life of our smaller meters is different than the ability for rehabilitation and life for our meters that are greater than 2 inches. So we can do a lot more work on our larger meters, and we build those rehab events into the model. So this is just kind of showing you how once you do the rehabilitation and how many there are, and kind of in that middle column, and then you can see what the post condition. So we don't necessarily say a post condition is going to go to a kind of a perfect 10, but once those are rehabilitated, we move them up to a condition of 9, so they're in pretty good condition. And then over time, as they degrade and or the condition information is back from the field folks comes in as it decreases over time, then we can add that in and trigger it in the model. And then that would say, okay, once you hit this trigger, then you need to spend some money, whether it's replace some of the valves or the meters or the hydrants, etc. And then the other nice part about AIMS is that here on the left-hand column, you'll see all of our primary asset classes in the hierarchy, as well as the sub-asset classes. If you're looking at the model statistics of the AMP administration in the middle, you'll see that we have just shy of 2,500 hydrant laterals. Generally, we have the right amount of information in those hydrant laterals, so we know the install year and the make and model and its useful life, and it has a management strategy with replacement cost. And for the few that we don't, we'll obviously have to go back and do some additional digging or sleuthing or some field work in order to make sure that we have all of the relevant data in order to make sure that we can run the model with its respective management strategy. And then last but certainly not least, when we knit all of those assets, again, there's just shy of 90,000 assets in our asset registry. We can get a longer term view of the system and its financial needs. So again, if you look at the 2020 to 2025 area, we've got our debt loads and capital improvement projects out, even past 2030 and 2035 when our loans are paid off, and you don't see too much in red in the coming years, again, because we're kind of that young frisky teenager of a utility that's still in growth mode. But there are some echo booms that show up later in past 2040, and especially in 2070 and 2090. And those 2090 dates are just it's the echo boom of large expansions in the district's past. So we have some aggressive growth in the 70s and 80s and 90s and 2000s. So what you're starting to see is those pipes that generally have around 100 years of remaining life starting to show up here, in the future. So again, it's not something that we necessarily have to manage, here in the short term. But even going back to that kind of the rock pile of that 2.5 million back in year 2020, those are things that we would dig into deeper, especially in Dan's ops world, where I'd ask him, hey, go look at these particular assets and see if they truly are, at the end of their useful life. And obviously, hopefully, some can be deferred for the next several years. But if not, we'll have to queue them up and create a CIP project for them as well. So again, here on the left is here's the the iceberg view. Is that for whatever good work we've done today, it certainly we were on a journey of many years, as Chris and Dan have already alluded to where, hey, to get into this position of being a success and being able to kind of map out what our financial picture is and our number of rehabs and rehabilitations we have ahead of us. That was all built on persistence and people willing to sacrifice their time and work a little bit differently. And yeah, we hit some roadblocks here and there, and we can't say that we've done everything perfectly, but at the end of the day, the hard work and dedication of everybody here at the district has helped put us in a better position. So just want to underscore these other points is that it's all about getting better. Again, nobody here is perfect, and we're just trying to get better every day and get better information in our systems every day. Since we almost have 90,000 assets in our portfolio, certainly you can't put that on the shoulders of one person. So it's good to have a team. We have an asset management committee that's formed with a person from every functional department. So everybody has the ability to provide input on what's going on from their perspectives, again, to get better results. Again, we're using these outputs to sell and tell our story, and hopefully that you can do the same in for your agency, because at the end of the day, if you're not managing your assets, your assets are going to manage you, and that's going to be in some sort of a financial hit or a financial tsunami. So in the case of Covington Water, we're just trying to stay ahead of that, given that we're still in a growth mode, but eventually that growth will give over to rehabs and replacements, and that's going to have to come on the backs of our ratepayers. It won't be financed by developers as it is today. And with that, we'd like to take any questions about our journey.
So if there's any questions from the group, we'll go ahead and take those now.
Well, so let me pause for just a second. That was fantastic. And the fact that one person applauding over a crappy little microphone, it just sounds terrible. I won't expose you to that, but I want to thank you for that presentation. That was very informative.
Thank you.
And Leslie, what's our chat?
So we have 3 questions right now in chat. And so the first one is, can you speak about alternatives to field GPS units for smaller or less technically savvy utilities?
I don't have much input there. Using an access database would be kind of an archaic way to keep an asset register, but it's certainly possible for those smaller utilities.
I would offer, this is Dan Sleeth, the operations manager. I would offer in today's world, if anybody's been privy or spent much time around Esri or gone to an Esri users group, the reality is most adults that I've been around at this point all own a smartphone. And if you go to Facebook or you go to Google or you go to Instagram or you go to Twitter, you can do in-field GPSing.
You just don't have the same level of detail.
Thanks. Next question. At what level do you consider a component an asset? Are you using initial value, years of service, life, or some other criteria?
So this is Tom, I can start. So typically in our asset registry, we tend to, kind of filter out things that are, around $5,000, and that's one cutoff. But we do get into more components in some of our mechanical systems if that particular component could be kind of a single point of failure, or if this isn't working, the pump station won't pump or the pump won't operate. So we don't do but say if, for instance, like on a hydrant, depending on the hydrant style, you could have, dozens of different parts. But in that case, we just track basically the hydrant.
Thank you. Next question. How much does your asset management program affect your current user rates?
So as far as what we're charging, I guess what we're trying to do is, since we're a younger utility and still kind of in growth mode, it's that future funding graph what we're using is, the goal is to, make sure we're either keeping our spending in check or balancing any needs against rate impact. In that one slide, I kind of showed the variability of our CIP program. You certainly wouldn't want to get to a point where all of a sudden you are kind of backed against the wall and having to do, tens of millions of dollars of rehabilitations because that would send your rate model into rate shock. So that's definitely something that we're, using and keeping an eye on here in the coming years, just to make sure that kind of that, that backlog or tsunami of need doesn't come, or if it is coming, we can start, spreading it out better so it doesn't impact our rate model and our rates as much.
Great. A couple more questions. If you have planned improvements, how much design do you have done ahead of time, or do you have the developer provide the design for the improvements per municipal specifications?
Oh, that's a timely question. I would say for most of the capital improvement projects that we do, if it's strictly rehab and rehabilitation, those are led for and paid out of the district's pocket. We do have a couple projects, or one big project with a couple of different phases where actually the developer is doing the design, and then we're just doing just providing a QA/QC check. And then for a kind of a more typical, like a subdivision, type of growth, again, we just do QA/QC. And then we do have some small projects that we might do in-house where we'll do some of the design ourselves. So that's a bit of a potpourri, or just kind of depends.
Great. And I have one more question, specifically for Dan. Can you give some specific examples of maintenance tasks that do not add value?
Yeah, actually, so when I first took over here, our control valve program, I'll pick on that. We had a backlog of numerous counts of the teams going out and spending time on control valves. And when I asked them what they were doing, the basic answer I got was, well, I was making sure the valve was running and that the pressures were correct. So I would use that as probably the prime example of it, a task that really wasn't providing any value.
Great, thank you. I'm not seeing any further questions, so I'll turn it back over to you, David.
Let me get unmuted. Well, and we're just a few minutes over time, but that was fantastic. I just want to thank everyone for Zooming in to the first day of our first ever online conference, and look forward to seeing you tomorrow for the day with 2 tracks, one transportation-ish focused and one tribal-ish focused. But yeah, to sign up for you'll log into the sessions that work for you, and we'll see you then. Thank you all.